Okay, hello. Welcome to this workshop on Primavera Risk Analysis. We call it Risk Analytics with Primavera Risk Analysis. My name is Jacques Alexis. I'm a faculty in the leadership and project management domain in CPS. So you know this meeting is being recorded and it will be shared with our learning community for learning purposes, of course. So the purpose of the workshop is to introduce you to Primavera Risk Analysis and talk about the importance of technology integrations to management, whether we talk about project management or operations management. We do need technologies to help answer certain questions. I'm going to show you the data set we're going to use. That's an example here. It's a Microsoft project file. As you can see, ID1 is the project, concentrations power plant. Here it's says WBS, but it's not only the WBS. We have project activities as well. So the estimated finish date of the project is going to be April 8, 2024. Now, a simple question that you may ask yourself: what is the probability of finishing or completing this project by April 8, 2024? The truth is you can't answer this without performing what we call a Monte Carlo simulations, and extremely difficult. And even I would say impossible if you have thousands of project activities to perform a Monte Carlo simulations without using a software applications. So that's one example. So you could ask yourself the same questions: what's the probability for me to complete this project at a certain cost or within a range of date, etc. So that's one of the questions we're going to use today. So this is why we are using Primavera Risk Analysis in this case. So we're going to start with lesson 5 and then move to lesson 6. Now, if you're asking how about lessons 1 to 4, the reasons we skip these lessons is because they're about how to create a plan from scratch in Primavera Risk Analysis. But this is not something we need. You will see that the user interface is going to be the same as Microsoft Project. Most of you already know how to create a plan from scratch. So what we're going to do in this workshop, we're going to import data from Microsoft Project, just one of the data set I just showed you here. We're going to import it in Project. So if you don't have lesson 5, just post in the chat and someone will share it with you, because I did send it out. So that's perfect. I see someone already posted it. Thank you very much, Stephanie. So so that's it. Now I would like to now, do you have any questions before we start? All right, so the first step we're going to take here is to open Primavera Risk Analysis. I'm going to give you a minute to open the software. If it's not already open, please, when you're ready, please type ready in the chat. So I don't want to leave you behind in case you want to follow along. Okay, I see some folks are ready. Now, do anyone needs more time to open the software? If you need more time, you can type 1 more minute, please. If I don't see anything, then I will certainly move forward. Okay, so everyone is ready. Okay, so this is the software. So what I'm going to do, I'm going to import my file, my Microsoft project file. So the file that I'm going to import is this file, the CSP plant file. So that's what I'm going to import here. So if you go to File and click on Microsoft Project, and you click on Open Project, it's going to take you to here. And I think these are the files that I want here. I am going to open this file. Okay, here we go. Here we go. So this dialog box is giving me information about some details of the plan that I'm importing. For example, planning unit is going to be in day, and 1 day, 8 hours, etc. So as you can see, the general setting is already all set here, because you want your plan to be in one-time unit. In Microsoft Project, it is not in one-time unit, but in Primavera Risk Analysis, everything will be converted into one-time units, which is going to be day. In Microsoft Project, it is in weeks and days, but here, when we open the plan, it's going to be in day. Now, after import check, if you want an import log to inspect, you check this box to do it. Since we will be talking about both cost and schedule, I want to make sure that I have a cost distribution selected, resources selected here. I want to import all project resources and assignments from Microsoft Project into Primavera Risk Analysis. And I want a distribution cost, which will be using 3-point estimate. 3-point estimates minimum, most likely, and maximum cost, right? So here. Now, if you want to remember the setting, click remember the setting. I mean, if you follow with me or you follow with whatever we're doing in the, whatever you have in the file, that's going to be perfect. Now I click OK, and I'm importing the data. Okay, so I'm going to save it. I'm going to now, as you can see, the extensions for Primavera Risk Analysis file is .plan, right? So remember that, .plan. So if you're looking for your file, it's going to say .plan. In Microsoft Project, it's going to say MPP. Now, I'm going to call this, let's say I'm going to put a number 1 here, or if you even want, you can put the today's date, 01/23/23. So you know this is the file you created by importing the data. So please save it in a place you're going to remember. So we, because we're going to use it later. Okay. This is your imported file. It's give you information about the finish date of your plan, right? Estimated finish date. And then you have remaining duration, which is the total number of days to complete your project, normal tasks, summary tasks, milestones, all information about the plan you imported. Now, since we can close this log, like if you want to, there are a lot of things you can do here. You can point it, you can save it if you want. But anytime you have data in Microsoft Project, you can always import it into Primavera to have a summary right in front of you to see what's going on. Let me close this. Now, what I'd like you to know here is that there are different types of files you can open with the software, apart from, in addition to Microsoft Project, Dell Tech, for example, files that Dell Tech is another project, another company, IT company that develops software for operations, project, portfolio management. You can open file from UNCFACT. The UNCFACT, as you can see in the instruction, is the United Nations Center for Trade Facilitation and Electronic Business. So Primavera, you can import file from Primavera P6, P3, etc. So it's compatible. Primavera Risk Analysis is compatible with a lot of other software. So this is what my ground view looks like in Primavera Risk Analysis. So the default view, just like in Project, the default view is the Gantt chart view. It has the list of the tasks with remaining duration. Now, the remaining duration is what I imported from Microsoft Project. Now, remaining duration is the same as most likely duration. So when you develop a plan in Microsoft Project and you say, for example, prepare stakeholder analysis is going to take 5 days, you believe that prepare stakeholder analysis is most likely going to take 5 days. Now, if you take a look at the right of my screen, you have mean, most likely, maximum durations, and task existence probability. When we say that we are going to perform Monte Carlo simulations and we have to model uncertainty in order for us to be able to do that, we mean that we need mean, most likely, and max duration. Same thing for cost. We need mean, most likely, and max cost for the project activities and deliverable. Now, as you can see here, it is empty. I will not be able to perform a Monte Carlo simulations because I didn't model uncertainty here. So I have to do that first. When modeling uncertainty, not only you need mean, max, and most likely duration, you also need to select probability distribution. And I'm going to show you how to do that. In project management, the most common probability distributions are triangular distribution and beta-hurt distribution. Now, these distributions are popular because they model well duration and cost estimate in project management. So what I need to model uncertainty, I already have the most likely estimate. So what I have to decide is, ask my team, can you give me an optimistic and a pessimistic estimate, minimum, maximum? So they will go and provide you this information. Now, you must work with people with knowledge of the project. Obviously, I can't tell you how long a pre-feasibility study is going to take for a power plant if I don't have any knowledge of the plant, the locations where you're building it, and the people involved, etc. So you need people to give you this information. However, here we can use the software to have a quick overview of the uncertainty involved in the project. So what we're going to do, we're going to use something called duration quick rest in order for us to do that. Now, the duration quick rest is something that tells you you have the most likely duration. Here it is called likely duration. So we're going to say this is 100%. In other words, just going to import the information or transfer the information as you imported it, 100%. You can say the minimum durations will be 75% of the most likely durations, or 50%. You can change this number here. As you can see, you can edit it. And the maximum durations is going to be 150% of the most likely durations. Remember, remaining duration is the same as most likely duration. If you feel a little bit more pessimistic, then, for whatever reason, you can actually change this to 200% or higher. Is going to be entirely up to you. Now, another thing you can do is to change the probability distributions. As you can see here, I have triangular, uniform, and beta paired. The two, if you're using 3-point estimate, triangular distributions or triangle distribution, if you prefer, and beta paired distribution is going to be perfect. They will be fine. Triangular distributions, if you are a bit more pessimistic, beta paired distributions if you have more confidence in the most likely estimate. That's why in the formula we say 4 times most likely, and the software is going to use the same formula. Optimistic plus 4 times most likely plus pessimistic divided by 6 to calculate the average estimate. For triangular distribution, if you put it on a triangular distribution, or if you select a triangular distribution, it's going to use a simple average. It's going to be the minimum plus the maximum plus the most likely divided by 3. So what I'm going to do this time, I'm going to keep it. I'm going to keep the beta paired distributions. It's a very good distribution. Now, another thing you can do here is to otherwise existing estimate duration and duration distributions nodes. Now, what does it mean? It means that if you had any information in this table, it will override it. If you uncheck this, it will only add additional information. It will not override any information you have. Now I'm going to check this because in this situation it's going to work without any problem. So I click OK. As you can see here, the information I need to model uncertainty. Uncertainty modeling means that you express your estimates in a way that to say that I'm not sure. It's maybe 4 days, 5 days, or 8 days. It's uncertain. Now, when you perform a Monte Carlo simulations, the software will estimate that the activity or the work package, whatever the case might be, can take value from 4 to 8. Pre-pair stakeholder analysis, when I say 4 minimum, 8 maximum, remember it could be 6 or 7 too, right? So it's going to be, between 4 and 8. Could be 4, 8, 6, 7, any number in this range, okay? So that's what you're doing when you're performing simulations, okay? So now, do you have any questions before we move ahead? Any questions? No? Okay, so if I select this task, right, and I click on risk and uncertainty, see, and so here I have the general tab, but if I click on risk and uncertainty, you can see the same information below. Here, I have the beta paired distribution I selected in duration quick risk, the mean, the most likely, and the maximum durations, and the shape of the data. Now, take a look at the thin tail of the distributions, it means that the extreme values are less likely to occur. But you see possibilities between 4 and 8. Here, everything is possible. Now, since you have uncertainty model in this plan, this is when you really can perform a risk analysis and Monte Carlo simulations. So I'm going to show you quickly how to do that, and I'm going to take questions and move forward with the rest of the instructions after we do that. Now, to perform a risk analysis, that's before we associate identified risks to WBS items and project activities. As you can see here, in my file, I do not have identified risks associated with them yet. So I'm going to run a risk analysis first, and then later we're going to identify risk, probability of occurrence, etc., mitigation actions, and then we're going to associate them with different parts of the project. And we're going to run the risk analysis again to see whether we have difference or not. So to run a risk analysis or to perform the Monte Carlo simulations, click on risk, right? And then click on run risk analysis. Now, here's my dialog box here. It's analyzed for 1,000 iterations. That's the number of iterations. The default is 1,000, but you can change it. What we have observed over the years with projects of different sizes, if a project is large enough to warrant the use of quantitative risk analysis, we've seen that 1,000 iterations usually produce reliable information for the project. Now, remember in IT, we say garbage in, garbage out. If your estimates are not accurate, your analysis will not be accurate. If your, how do you call that? Your estimates are wrong, then you're certainly going to have a problem. Now, when you run the analysis, there are a lot of things you can do here. You can say show step through analysis options. In other words, every time you pick a possible durations, let's say for high level planning between 6 and 12, you can see every time the computer select a possible durations for high level planning. You can also choose to show the distribution graph, right? When afterwards, after this simulations or the analysis is complete. Or you can show the tornado graph, a scatter plot, or a probabilistic cash flow. I do have instructions about probabilistic cash flow in the instructions. However, it is most useful when you're working on predicting cash flow for a project. Like say, you're working on capital budgeting. You're trying to figure out, I'm investing in this project. What are the cash inflows and the cash outflows? Now, here we only have cash outflows. We're not going to have cash inflows because we didn't enter this information here. So we're going to work from a cost management perspective, not revenue analysis. So that's one thing to keep in mind here. So I'm going to select the distribution graph later. I'm going to show you why would you choose the tornado graph, because we're going to talk about sensitivity analysis and criticality. Then that's when we're going to name the tornado graph, right? So right now I'm going to click analyze, right? So one step is one iteration. You can see how the gun bars are moving from the software selecting different possible outcomes. From red to blue means sometimes those activities are on the critical part, sometimes they're not, right? Now, to go a bit faster, we're going to click on Go. Here we go. That's the software performing the simulations, picking different durations for the project activities. And if you click complete, it will go even faster. There we go. Et voila. That's the result of our simulations. Now, it looks like we have questions in the chat. Sorry for, what was it, tornado or distribution? Well, I choose the distribution graph in my case. And that's what we're looking at here. We can always go back and find the tornado graph after you run the analysis. Both the distribution graph and the tornado graph will be available to you in reports. I'm going to show you this later. So this is our distribution graph. Now the question is, what does it tell you? It gives you enough information to actually negotiate with your sponsor. Someone is speaking. Can you please mute yourself? Thank you very much. Okay, so here the distribution graph is called a probability distribution, because a probability distribution is a means of associating a probability with different possible outcomes. What you're looking at here to the right are possible completion date of the project, right? And associated probability. For example, the date deterministic here, April, so it is in French here. So what you look here is going to be the day first. So that's the day first of April, April 1st, deterministic. So as you can see, the estimated time you got when you work with your teammates to estimate the duration of the project, the most likely durations, the probability to achieve this or to complete the project, to achieve this target, is only 2%. It's very low probability. Now, if you entered information, accurate data in the software, this is credible information to negotiate with your stakeholders. Say, hey, I know you want this project first week of it. However, the probability for us to achieve this is going to be very low. Chances are we will be able to complete it by December 26th. So that's after Christmas. So the sponsor may not agree with this, but at least you know the probability for you to achieve your target from a schedule perspective is going to be very low. Now, you have an 80% chance of finishing this project by December 26th and 50% chance of completing it by October 10, 2024. Now, when you're working with the software, there are things that you must know. The software, there is no artificial intelligence or software applications that can replace your judgment as project manager or as a human being. For example, you need to know in terms of estimating completion dates, it has to be something in the future, right? I could perform these simulations with dates in the past, but it wouldn't make sense because risk and uncertainty are about the future. So you need to make sure the completion date of the project is set to a future date, right? If you take here, you can take a look at 75% and associated date. You can click anywhere in the graph to see, you know, what's the date and the probability associated. That's what we call a probability distribution. Okay, so let's see. Do we have any questions here? When I try to run this analysis, it crashes. Oh, yeah. So I don't know why it crashes then. Okay, so we have a questions here. In the left side where you have the project list of activities, why some are red, others are green. So in the software, generally we use red and green to represent critical and non-critical activities, depending on whether we're looking at activities that are always on the critical path, sometimes on the critical path, etc. So that's what we use this information. But when we take a look at the tornado graph, I'm going to talk a little bit more about this, so don't worry about it. I'm looking at solutions was crashed 3 times in a row. Okay. I don't know. I'm not certain. Are you using the software on your own computer, or are you using it on a virtual machine? What's your situation there, Stephanie? On a virtual machine. I believe it might be connection problem, internet connection problem. In a case like that, what I would do if I were you, I would probably close my computer or reboot, that's the language for it, and see what happened. But I know if you reboot, it's going to take a while in order for you to come back. Would you like to do that? Would you like to reboot your system? It will take a little while for you to go back to the machine. Or maybe okay, perfect. Okay, perfect. So now finish date. This is the finish date distribution. You can take a look at, obviously start date is not going to be a problem, but duration. Let's take a look at durations in days. It is another, you have another distributions here. You can talk about durations in days with associated probability, but you can also talk about a specific date or a date range. All right, and we can take a look at cost distribution. That's the cost distribution. So that's and you're only going to have a cost distribution if you had resources associated with different parts of the project or on the project activities, and with a pay rate for those resources. If you didn't do that, you're not going to have a cost distribution. So this information is actually pretty useful. The deterministic estimate for the cost of the project, as you can see, $813,000 approximately, probability 12%. And you can see the 50% probability, that's what we call your P50 and your P80, probability 50% and probability 80%. Now, we don't have MVP data, we don't have IRR data, we didn't enter this information. This information is useful when you're working again with project revenue estimates. We're not working with this this time. We're working only with schedule and costs. So that's the first part of this, and the second part we have already done. I'm going to close this graph and save it, right? The second part, we already work on it. That's the entering 3-point estimates. We, as I explained, you can enter this information manually by typing in this table, or you can use duration request to go faster if you're just trying to demonstrate and take a look at uncertainty model for your project. Okay? Questions before we move to the next part? Questions? No? No questions? Okay. In part 3, we're going to work with something called task existence probability. So to demonstrate these functions, we will use the file software for the software development project. And you do also have access to that. So what I'm going to do here, I am going to close, I'm going to save this. Remember where you save it. I already save it. And I give it a name. So we're going to come back to it, but I'd like you to open the other file to demonstrate the idea of task existence probability. So let's close this. And we are going to, okay. I didn't actually want to open this. I wanted to close just the file. But right now I'm going to open Primavera again. This is the file that I'm going to use, this one. I'm going to import it to Primavera Risk Analysis. Microsoft project, open project. This one. And we want this one. Okay. You already know about this. If you want to change the setting, you certainly can. I want cost distribution. So I make sure these are selected and I import the data. I'm going to save it as plan 1 or plan 2. I already have one here. There we go. This is our Microsoft project import report, right? And this is the Gantt view for this file. If you click on plan and click on plan information, you can see informations about the plan here. This is a project with an estimated finish date of August 30th. So it is in the future. We don't have any problem with that. You can fix plan finish dates in project or in Primavera Risk Analysis, right? So dates, that's fine. Okay. Task existence probability. Before we start, let me, wait for you if you need to work on this. And questions. I'll take some questions. Do you have any questions? No questions. Okay. So what do I need to perform Monte Carlo simulations here on this file? Anyone? What do I need? I can try run risk analysis. 1,000 time situations. This time I can choose the tornado graph, or I can choose the distribution graph, analyze. And it is not possible to run the risk analysis as there is no uncertainty in this plan. So what do I need to perform the analysis? What is missing? Okay, someone's telling me in chat, I am missing the estimates. Okay, this is true. Now, I'm going to do the same thing I did before. I go to risk, duration, quick rest. And if I want, I can work with the triangle distribution this time. A uniform distribution means that you only have two estimates, the minimum and the maximum. And obviously, when you perform simulations, the durations of an activity could take any value between the mean and the max, including the mean and the max, but any values in between two, right? So I'm going to use the triangular distributions this time, and I click OK, right? My mean and max, optimistic, pessimistic, are based on the most likely number. What does that mean right now? It means that I have uncertainty in the plan. If you go back, you can run the analysis. Analyze, go. Here sometimes the bars are red, sometimes they blue. It means it's the simulations here. The tasks sometimes are critical and sometimes they're not. That's what it means, they're moving from red to blue. And complete, you have information. So when we work on the tornado graph, I'm going to show you tasks that are, have a high, the tasks in red have a high correlation with the project durations, or they are always on the critical path, or the correlations between the durations of those activities and the project durations are going to be high. They are highlighted in red to attract the attention of the project manager on those activities. And we're going to talk about deficiencies in the software where human judgment is required to make sense of the result. right? So this is my distribution graph again for this, with my with possible dates to complete the project and associated probability. I'm going to close that. I can save it, right? And what I'm going to do right now is talk about task existence probability. Now, when you develop a plan, you may find yourself in a situations where some of the activities in your project may or may not exist when you run a simulation. And the reasons for that is the nature of the task itself. Let's say you were working on a software development project. In this case, it could be, you know, a drug development project, could be a construction project, in any situation. The assumptions here is that we are using, if we are in software development, we are using a predictive or a hybrid development approach. In a hybrid development approach, you have a complete plan for the project, but when you're actually developing it, you use iterations or sprints to develop the software. In this case, we have a complete plan for this project, and we have an activity called fix bugs after we test the software. As you can see, we are in beta testing at this point. Now, there is a chance that the activity fix bugs may not exist. And the reasons for that is because if you can develop a software and with no bugs, so the activity fix bugs that's going to take 10 days, you're not going to do that. So the project would actually, you'd be able to shorten the duration of your project. A good scenario is when you imagine the quality of your software developers. If they are very good at what they do, then you could find yourself in these situations where you develop a feature and the feature doesn't need any fixing. So what we're going to tell the software here is that there is a chance that fix bugs exist. So if you right click on it and you click on existence risk, right? And it's open right here at the bottom, risk and uncertainty, you could, you know, do that too. And existence risk, we're going to turn it on, right? We turn it on. Now, the probability this task exists is 100%. So what we're going to tell the software, actually, you know, the probability this task exists based on my team or my developers' knowledge is only 40%, right? So that's what we tell in the software, actually. And when you run this analysis, it means that sometimes fixed bugs will be included and sometimes it will not. As you can see here, it's already showing here also in the gun bar, but also in the task existence probability column here, right? So when you run the simulations, now, if we say run risk analysis, analyze and go, sometimes, as you can see, it's moved from yellow to dark gray. Sometimes it is included, sometimes it isn't. That's what's happening here. And I leave it like that for you to see it. And we can complete this. There we go. I think actually there is an improvement in the deterministics. Now, if my memory is right, it doesn't betray me, deterministic was like 12% before. I can't remember, but in order for you to remember, when you run simulations with different scenarios, is to take notes or, you know, save your file to make sure you can compare and contrast, right? So that's what you have here with task existence probability. Now, any questions on this?
Professor, as you mentioned this risk existence, right? Can we change the duration as well for a task?
If you can change the duration, yes. If you have new estimates, absolutely, no problem at all. You can change the most likely estimates if you want, or any estimates if you have informations to change it.
Okay. And Professor, this deterministic 20%, right? It is like based on the task that is started, or it is taking like an initial steps, initial startup tasks. Because I noticed like when you uploaded, there were few tasks which has already started. So is that depending on that, or it is a kind of like approximate deterministic before the starting of the project?
Well, there are a number of factors that are taken into considerations, and I am very happy you observing actually some tasks already started. And the reason for that is because the date and the start date of a project is in the past. But in order for this to happen, you must report progress in the software saying, we already started these tasks, and we have some sort of percent complete on it, and the software will take this into consideration. For example, if I run the simulations and there are tasks that are 100% complete, the simulations will not take those tasks into considerations because there is no uncertainty involved in a task that is 100% complete, right? Does that make sense? So this is one example one thing to keep in mind when you run the simulations. So the deterministic date or estimates, probably they are based on our estimate, our knowledge, sometimes vendor quote, we find this information, and then we ask ourselves, what would be the deviations? In one situation, it could be because you have 3 estimates because you call 3 vendors.
Exactly.
And every one of them give you an estimate of how things will work. Because developing a plan, a scheduled plan and cost for a large scale project like that is a massive endeavor. And it requires, the collaborations of a great team.
Professor, I have one last question.
Absolutely.
Yeah, while you're uploading that, I notice that there was like a remaining duration. It should be like a total duration for the task, right? The remaining duration, I'm just confused there.
Okay. The remaining duration is a language used in Primavera. Now, remaining durations mean, it could mean the entire estimate if the task, hasn't started yet.
Okay.
Or it could be remaining durations because we started to work on this task. There are 5 days left to work on it. Does that make sense? So if I create a plan today, and for a project that will start next month, and I haven't done any work on the project yet, in Primavera Risk Analysis, my estimates will be called remaining duration. It's just the language they use. It's the most likely estimates is what Microsoft project called duration. They call it remaining durations. But sometimes it may have a 2 meanings. Could be I have 5 days left to work on this task, but I started working on it. So that's why they use this language.
Okay, thank you so much, Professor.
Absolutely. Any other questions before we move forward? Okay, so we show examples of finish date, duration, uncertainty, and cost uncertainty. Now, we can actually start talking about the idea of what we're going to cover now. We're going to cover criticality index and schedule sensitivity before we move to move to the next part, to lesson 6, right? So that's going to be interesting. I know it's very difficult to go. We've been working here for almost an hour. It might be a lot for folks, but we certainly going to do it. We're going to make sure we cover everything. And if you need anything, if you have questions, know that you can ask now or later. There is no problem at all. Okay, so I'm going to close this, right? And I have to make sure that I do not close Primavera Risk Analysis this time. We're going to talk about criticality index. So for this criticality index, let's see if I need this plan or another plan. Okay, I think we can certainly work with this. That's not going to be a problem. Now, when you run the risk analysis, you actually generate a lot of information. You generate not only the distribution graph, but also if you take a look at report, you can see a lot of other things you create. In addition to the distribution graph, you also generated other informations. And one of them is the tornado graph, right? For this project, I'm just going to click on it, right? I have schedule sensitivity. Take a look here, schedule sensitivity. And I do have duration sensitivity. I have cost sensitivity. And I have criticality index. Also duration causality, right? So let's start in order. So the order in the instructions that I started with criticality index. Now, why did I start with criticality index? Because it's very common in project management, and you'll hear people talk about it all the time. It is not something that exists only in project management. You can calculate criticality index in different fields, but here in project management, we're going to take a look at here. Now, some of you, remember you asked me why some of the tasks were red in the entire plan in the Gantt view. Now, if you can remember, tasks like post-project review, initiate project, plan project, development, they were all red because they have high criticality index or high correlations with the project. And I'm going to talk about this in a minute. So the critical index, the criticality index allows you to identify project activities that are likely to cause delays to the project. And when they ask you, what are the activities or tasks in your project that are likely to cause delay, that's what they're talking about. They're talking about correlations between your certain project durations, or how often they were on the critical path, right? And if you take a look to the right, there is a definition for everything, which makes it, the software very user-friendly. It says the criticality index of a task is the proportion of the iterations in which it was critical. For example, I run this iteration 1,000 times. It means that post-project review has a criticality index of 100%. This means that for every single iteration, it was always on the critical path. Initiate project, plan project work, direct and manage project work were on the critical path 71% of the time. And as you can see, the other activities were equally on the critical path for listed here, at least those activities listed there, 31% of the time. This information, so I think, is an opportunity for the project manager to pay attention to. Now, the problem with the criticality index, it doesn't tell you how important a task is for the completions of the project. As you can see, post-project review, initiate project, plan project work, direct and manage project work are all project management activities and deliverables, right? They are not scope deliverables. And you wonder, you know, if you know, something happened to planning, of if you didn't finish planning before you start the work of the project, what would happen? Now, and direct and manage the work of the project, you obviously have monitoring and controlling, right? And you are ask yourself, you know, how important is this monitoring and controlling in a self-managed team? Perhaps the project would do fine, you know, by not paying attention or much attention to it. But the truth is, we know planning is important. We know monitoring and controlling as project management processes are actually very important things to pay attention to. So that's what we're looking at here. So what else we can talk about? We can talk about limitations. We can certainly talk about duration sensitivity here. Now, it's defined here for us. So duration sensitivity of a task is a measure of the correlation between its durations, the durations of the task, and the project durations, right? So there is a strong positive correlation between the project durations and the activity direct and manage project work. And the tricky part here is that when do you start manage the work of the project? It's something you start doing project execution, and it doesn't end until the end of the project. As you can see, there is the direct and manage project work would be what we call a hammock activity, because it will encompass the entire execution phase and contain some of the elements of the closing phase until you have customer acceptance. So the longer an activity is, a hammock activity, for example, would have a large correlation with the durations of the project. So that's what you're looking at here. So when we talk about correlations here, the software use Pearson's product moment correlations, which take values between -100 and -100, +100, or -100 to +100. So it could be, correlations could be a negative value with inverse correlation. Sometimes you may find yourself in a situations like that, right? And cost sensitivity will be actually the same thing, correlations between the cost of an activity and the cost of the project. As you can see here, those are the largest costs of the project. So it is a software development project, obviously. There is a 100% correlation here. Project management is very expensive in the project. So that's what you're looking at here, right? So you have informations to the software allows you to generate informations to present to your stakeholders. One of the things we talk about cost sensitivity. We can talk about schedule sensitivity index here, right? The schedule sensitivity index of a task is calculated by multiplying its criticality index. We already talked about that, by the ratio of its variance against the variance of the project. We call it task variance right here. All right. So that's what you're looking at, schedule sensitivity index. 85% for those tasks, for this direct and managed project work. Now, I don't know if you remember the 880 rule for work breakdown structure. When you breaking down your project into project deliverables and work packages, the 880 rule for work package is the idea that if you have a work package that's going to be longer than 80 hours or 2 weeks, then you should break it down a little bit further. Now, and this is translated into the software. The longer a task, the riskier it is. So it's because it's going to be more complex. It's because it is more likely to have correlations with the durations of the project. It is likely people, get distracted before they complete it. So all those aspects, from mathematics to psychology, all of it, take into considerations to develop a software application. So a lot to think about. So this is why we need the expert when we develop this software. And obviously, duration causality here. The causality of a task is calculated by multiplying its duration sensitivity by its criticality index. Again, you can see the same patterns here for the activities that we talked about earlier. So for this lessons, we're not going to talk about cash flow because we didn't enter cash flow information. But if you want to use the software in capital budgeting, for example, and you have questions, please, feel free to reach out. Any questions here? Do you have any questions in the chat? Let's take a look. I don't see any questions in the chat. And I can close this. I'm going to save my draft, and then we're going to move to lesson 6. This is lesson 6. All right. So lesson 6 is going to be a shorter lesson. So we're not going to. We are actually almost done here. Right. Okay, so in lesson 6, what we're going to cover, how we work with the risk register, and with Primavera Risk Analysis, we're going to see how we can actually map risk to work breakdown structure items or schedule items, because we can map risk to WBS items or project activities, right? So these are the things that we're going to use. So I am going to ask you to follow this instructions to open Primavera Risk Analysis. Now remember, there is a video here on this already. I broke this down because sometimes, watching 2 hours, a 2-hour video is going to take a long time. But if you want, you can just watch this. That's going to be about half an hour, working with the risk register with Primavera Risk Analysis. Part 1 covers a lot of what we're going to cover here. So what I'm going to do, I'm going to close this. Now, don't close Primavera, just the file, right? And say yes, and leave Primavera Risk Analysis open. Now, do we have questions before we move forward? Any questions? Questions? All right. So working with the risk register, let me look for my file here. So I'm going to open the file I was working with. I'm going to say file, open recent file. And I think I saved this file here, the CPS plant that I saved. I'm going to open it. And I don't need to re-import it because I already have it. So this is the file, right? Right now, the risk register is empty. I'm going to show you that. If you click on risk and you click on register, there are two ways. If I click on use standard risk register, it's going to take me to an empty risk register. You can actually do that. I'm going to give you time to do this if you need time. If you're ready, just type ready. Everyone, are you ready? Okay, ready. All right, so let's take a look here. 3 ways to enter data. In project risk management, after you create a risk management plan, the next thing to do is to start identifying risks, right? So when you identify risks, you enter this risk in a risk register. Now, you can enter your risk directly into Primavera Risk Analysis, but you could enter your risk into a spreadsheet and then import them into Primavera Risk Analysis. If you have a good template that will match the mapping of the risk register in Primavera Risk Analysis. So I'm going to first open this using the standard risk register, and then we're going to import an existing risk register. Right? That's what it looks like, an empty risk register in Primavera Risk Analysis. Right? Now, what do I have in the user interface? As you can see here, I have the File tab, Edit, View, Tools, Reports, and Help, right? Now, if you click on Edit, you can edit the risk scoring system, which is important for performing qualitative risk analysis. You can work on your work risk breakdown structure, and you can define, fields that you want to create. Now, if you click on risk scoring, for example, this is what you have. Now, why is it important to edit this? As you can see, I already have some default informations here, but it is important that I create a risk scoring system that is relevant to my actual project. For example, there is a probability scale. The probability scale here is a 5-point scale from very low to very high. And there is you have the probability values. The probability values tell you, what do you mean by very high? In this risk scoring system, it says that very high means anything that is higher than 70%. And high is anything that is higher than 50%. Now, you can change this information. So you can edit it and type new information. For the tolerance scale, you tell the software, when does a risk belong to the red zone, the yellow zone, and the green zone? Here you tell the software any risk that has a risk score higher than 23 will go to the red zone. And anything higher than 5 will go to the yellow zone. And anything 5 or less will go to the green zone. Now, if your organization's risk tolerance is different, then you're going to change it. For example, for me, in my company, anything high is anything that is higher than 30. So I have to go and, customize this according to my organization's risk tolerance. You can change the scale you use, 5-point scale here, and 3-point scale there for risk tolerance. Low, medium, high, very low, very high. You can change things here, right? Now, for impact scales, you have a 3-impact scale system where you can have schedule impact, cost impact, and performance impact, with the system telling you, what do you mean by this? For example, for the schedule, very low is anything equal or less than 5 days. Now, this isn't true for all project. There is no one size fits all. Now, if your project, for example, is 100 days project, maybe this is going to be different. If your project is a 2-year project, you may want to make some adjustment. And same thing for cost impact, right? And I mean, performance impact, it makes sense here that you could leave it like this for many projects because it's about meeting requirements, right? But for cost, time, scales, for the risk matrix, whether things are in the red zone, the yellow zone, or the green zone, you can do that. As you can see, this risk has a score of 24. Then it is in the red zone, is because in my tolerance scale, I told the software anything higher than 23 should go in the red zone. The risk score is calculated by multiplying the probability by the impact on the scale. As you can see, this is what happens here. Scale, the impact, I have impact scale from very low to very high, all right? And that's what they use here to calculate this. All right, questions? Now, this is all about editing. I'm showing you can edit things here, all right? Questions? No questions? Okay. Do we have questions in the chat? Oh, what is manageability and proximity for? Okay, so some risks you identified are going to be easier to manage than others. So if you want, when managing risks, you can create manageability factor to take into considerations how difficult a risk is to manage. Now, proximity is how close you think the risk is from a temporal perspective. Do you think it's going to be in 2 months, 3 months, or 6 months? That's proximity. Manageability is about difficulty in terms of management difficulty. So here I have 2 tabs. I have qualitative. This is the qualitative tab. As you can see, you can enter things manually. Risk ID, you can give them any ID you want. For example, R1 or R001. That's risk number 1, whatever you want to call it. Whether it's a threat or opportunity, that's what you have here, TO. When you enter it, for example, if I enter, let's say, risk R001, and it's going to ask me, is it a threat or an opportunity, right? And I have to say it's a threat. Now, the truth is, it could be an opportunity, but the truth is project managers don't spend much time managing or dealing with opportunities. They actually want to identify and take care of anything that may impact their project. That's what they pay attention to, all right? So that's what you're looking at here. Okay, now other questions. Do we have other questions here? You can, I just deleted what I started to enter. Practically the way this works is you fill this out. Later, we're going to talk about the difference between pre-mitigation and post-mitigation. Pre-mitigations mean I identify the risk, I have a probability for it, I have potential impact, I have a mitigation plan. But before I invoke the mitigation, so before I apply it to the risk, this is my scenario. And what if I actually invoke my mitigation plan and apply it to the project? What then happen to the probability of the risk? So if you want to reduce the probability of a risk, if you take any action, then the probability of the risk may be reduced. So that's what we're going to talk about here. Now let's take a look to see if we have questions in the chat. Can you please give an example of opportunity in risk? Yeah, well, there are a lot of examples of opportunity. For example, if I'm working on a project plan, a great opportunity to reduce duration and costs would be using something that I've already done, like a template, etc., to accelerate my work. That would be an opportunity in a project, or the opportunity to negotiate with a vendor, reduce costs based on the opportunity to purchase by a larger volume if you have more projects in a portfolio. A lot of examples of opportunities that I can give you. But project managers spend most of the time trying to identify this here for the project. So what am I going to do here? I am going to import risk register, right? This will replace any existing data in the risk register. Are you sure you want to continue? Yes, I want to continue. So where is the data that I want? So I'm going to tell the software the data that I need is actually an Excel spreadsheet. It is an Excel spreadsheet, right? So when you change that, it shows you your two spreadsheets here. You can pick one or two if you want. So I'm going to wait for you to be here so you don't have to. When you click import, it's going to confirm again. Do you want to delete this, replace that? Just click yes and yes and yes. That should be fine. And it's importing our data. And here's our data. Now, this is data from Excel. I don't know if I showed you, this is the spreadsheet that I use to import. It just import anything I had here. Qualitative risk analysis already have a bunch of information that I needed, right? And it just import the data. There are 4 tabs here. I have qualitative tab, response action. I have quantitative, task impact, and then I have risk history. So if you're a project management student, chances are you'll have a template like that to fill out. You have to fill out all tabs in order for you to have a complete risk register. So that's what we're looking at here. I'm going to go back to the software, all right? Opportunity, again, someone asked me what is an example of an opportunity. Reuse previous design work. That's an opportunity. It's giving me the opportunity to reduce things, reduce costs in my project. Okay, so let's start working with qualitative risk analysis. And you can look at mitigation informations that you have here with detail. You can take a look at the waterfall chart. The waterfall chart will show you how a risk evolves over time from pre-mitigations to post-mitigations. We're going to see this in a minute. So from quantitative risk analysis, I can show you there is pre-mitigations and post-mitigations. So pre-mitigation, first you need to tell the software what are the risks you're going to quantify, because qualitative risk analysis is about prioritizing risk. I've been talking for a while now. If you're going to quantify a risk, you check this box. Here, I'm not going to focus on opportunity. I'm not going to check that, but I'm going to key resource unavailable, contract delay, I'm going to do that. Design changes, I'm going to do that. So I select it. For understanding and detail and specifications, I'm going to choose that. And also testing fails, I'm going to choose that. System failure already have very low probability. I could ignore it if you want to, but ignoring risk, you know, is something that one of the things that requires your judgment to tell whether this is something you should ignore or not. Now, impacted tasks. Impacted tasks is where you link identified risks. These are the identified risks and the associated probability. And then you're going to link them to different part of the project. Now, A190, A130, A070 are project tasks. I am telling the software, this risk may impact all those three project activities. So in other words, you can associate a risk with the entire project, with one activity, or with many activities at the same time. So that's what you're looking at here. Now, do you have a question in the chat? Why are risks not in order in the register? Because I didn't order. Risk 1 and 2, when you are ordering risk in a risk register, it's not according to risk 1 to 10, is from the highest score to the lowest score. So it is possible that risk 4 has a higher score than risk 6 than risk 1. So that's how you order a risk in a risk register. It's not by the ID, it's not by risk ID, but risk from the highest score to the lowest. So this is my quantitative, my pre-mitigated tab. I'm going to go to the post-mitigated tab. Now, as you can see, after I invoke my, after I apply my contingency, not my mitigation plan, the risk probability reduced from what? from 60% to 5%, very effective. Thing change from 60% to 5%. Now, how about the second? From 60% to 20%, not so bad. Delivery of error here, from 40% to 20%. Post mitigations. How about this I didn't select? You can say, well, it goes from 40% to 10% if you want. Just type it. Hold on. Try you. Pre-mitigation. Post-mitigation. You have task view for your risk, and you have risk view, task view. When I click, sometimes I click by mistake on the task view, but I want this view, right? Risk number 9, I select this one. It was number 9, 60%. Let's say it's now 10%. Testing fail, it was 20%. Post mitigation, can it be 5%? Right? So after you do all this, you link risk to impacted risk, and you tell the software how your risk change. You can perform a risk analysis again to see what happened. For example, here, if I go to qualitative risk analysis again, and I click on, let's say, this one, the waterfall chart is telling me you have this risk, key resource unavailable, that had a risk score of 56 and actually had a risk score of 0. And that's what you're looking at now. The scale is here from 0 to 100, and it goes from 56 to 0. That's pretty good, right? And this is perfect. Now, once you do something like that, you're done with it, you can build what we call an impacted risk plan to see what's happened to your plan after you do all this work. From pre-mitigation, post-mitigation, I select both of them. So what I'd like you to know, a good thing to do is to take note of what happened before you do all this work, and to after you do it, what happened. So we're going to build this. Let's click OK and OK. And you have your scenario here with risk, with a list of project deliverables and activities with risks associated with it. Now, what you can do is to run the risk analysis again. And see whether you have any new scenarios for your project, because this is actually a very different plan. It didn't have the risk associated with them in the first place. Let's click on complete. And which plan is that? This is the CPS plant. You can, if you had different scenarios before, you can take a look to see, what did happened to my plan after I did all this work to see what's going on here. All right. So that's actually one of the things we do with the risk register. Let's see, import data, we've done that. We can add risks manually. And we have shown the waterfall chart. We work with pre-mitigation and post-mitigation data. Well, it's look like we've done quite of what we're here to do. So let me close this. And then I'm going to, I could go to report and take a look at the tornado graph again. Let's see, criticality, criticality index, and for other informations. We can always go and revise everything we've done to see what happened to our plan. Let's take a look at the chart here. Do the probabilities migrate into your plan after you develop your risk register? Yes, they take a look at the probability of the risk occurring when you are running the new risk analysis. All of this will impact your analysis, whether a risk may or may not occur. And the reasons for that is because, remember, you have, when you say you identify a risk with an impact of 5 days, based on the probability of the risk to occur, sometimes that 5 days may be added to the part it is associated with the project, or sometimes it will not, based on the probability. Just like task existence probability, that's the same thing. Where would you see what? You would see, where would you see the risk or the difference? You'll see the difference in the distribution graph by looking at the new, by looking at the task and associated probability. Obviously here, if you take a look at my Gantt chart, you see I have a list of risks here added to the project in the Gantt chart view. These are the risks associated with the project and how they might impact your project. Obviously, there are many factors to take into considerations. The date, the start date, we talk about start date and end date of a risk. We talk about proximity, how that might impact you in your project. All of these factors will take into consideration. For example, here, as you can see, I have dates start and finish that are in the past, which actually doesn't make any sense, because for your project in risk management, always have to be in the future. Now, the past dates were in my spreadsheet. I didn't change them. I just imported it without sense. So in your course, project risk management, always make sure that all estimates and for starts, finish dates of things will be in the future. Because you'll be working on a new project. So if you're using those templates provided to you in your risk management course, remember, you can always change the plan information. They just provide it to you as example, but you certainly can change them. So is there a way to add them to the Microsoft project file? Unfortunately, Microsoft project does not have this feature to add a link task to it. But what you can do actually is to add Primavera Risk Analysis as an add-on to Microsoft project, because they're compatible, and actually you could add it to Microsoft projects, and it becomes just like a feature in the software. That's the only way to do it. But if you don't do that, there's no way to do it in project, right? So that's one way to do it. You can add Primavera as an add-on to project. So instead of importing data, you can just click on Primavera and do everything right there in project. They definitely compatible. This is Oracle. Primavera is an Oracle product, and Oracle and Microsoft actually have a lot of collaborative projects, and Primavera Risk Analysis is one of the software where they have been working together to make sure they have features that are compatible. Okay, any other questions here? Do you have any other questions in the chat? No? Okay, so let's go here. Okay, perfect. So if you don't have any questions for me, it means that we are very effective. That's going to be all. But remember, it doesn't stop here. If you have questions, do not hesitate to reach out. I can always, send you information, resources you may need if you're working on so. Professor Jacques? Avi?
Yes, sir. I'm here.
Oh, you are. Yeah. Questions?
I was on mute. No question on my end. Thank you very much. This was extremely helpful, and I'm looking forward to more of these. And I'm happy that Dr. Alexis, that you have this website on YouTube. I think that is fantastic for all of us and the students.
Absolutely. So what I'm going to do, I'm going to post this on the channel. Remember, this is our channel. Subscribe to receive alerts when the video is posted. Okay. So if you don't have any questions for me, that's going to be all for now. And good luck with your projects this time. And that's going to be all. Thank you. Let me stop this recording and